Granite, the hardest natural stone on Earth. So hard that modern diamond-tipped drill bits spin at thousands of RPMs just to scratch its surface. And yet, standing before you right now, the Great Pyramid of Giza contains over 80,000 tons of granite, cut with surgical precision, fitted together so perfectly that a human hair cannot slide between the joints. Here is what should stop you cold. The ancient Egyptians did this without steel, without power tools, without industrial machinery of any kind. And they did it 4,500 years ago. Before you scroll away, archaeologists have found the actual tools, and what they discovered has been silently rewriting everything we thought we knew about the ancient world. Stay with me, because this story is far stranger than anything you've been taught. Let's start with the granite itself. Granite scores between 6 and 7 on the Mohs hardness scale. Copper, the metal the Egyptians had in abundance, scores a 3. To put that in terms you can feel, trying to cut granite with copper is like trying to carve marble with your fingernail. You don't scratch the granite destroys you. So how? That is the question that has haunted geologists, archaeologists, and engineers for over 2 centuries. How did a civilization with no steel, no iron, and no power tools quarry, transport, and shape millions of tons of the hardest stone on Earth with an accuracy that modern CNC machines struggle to replicate? The answer begins not in Cairo, not in a museum, but in the desert heat of Aswan, 500 miles south of the pyramids, where the ancient Egyptians ran the most important granite quarry in the history of human civilization. And inside that quarry right now, there is a stone that was abandoned 3,500 years ago, still attached to the bedrock, that tells us exactly how they did it. It tells us, and it horrifies engineers every time they see it. The quarry at Aswan is where this story truly begins. This is where the red granite of Egypt was born, the same granite that lines the king's chamber inside the Great Pyramid, the same granite carved into the colossal statues that stood before Egyptian temples for 3,000 years. Archaeological surveys conducted at Aswan, published in peer-reviewed studies by the Oriental Institute of Chicago and the Egyptian Supreme Council of Antiquities, confirm that this quarry was actively worked as far back as the Old Kingdom, around 2600 BCE. Workers here didn't just chip away randomly. They organized, they systematized, they industrialized without a single machine. Here's the first real fact that should shake you. They started by fire. Workers would build enormous fires directly against the granite face. Fires sustained for hours, sometimes days. The granite would heat unevenly because different mineral crystals within it expand at different rates. Quartz expands faster than feldspar, feldspar faster than mica. This creates internal stress lines. Then, at precisely the right moment, they would pour cold water on the stone. The thermal shock cracked the granite along predictable lines. This is not speculation. French Egyptologist Jean-Philippe Lauer documented firecracking evidence throughout the Aswan quarry in the 1930s, and modern experimental archaeologists at the Institute for Ancient Stone Technology replicated the technique in 2009. Achieving clean fracture lines within 3 centimeters of their intended targets on raw granite blocks. But fire was only the beginning. Because once the Egyptians cracked the stone free, they had to shape it. And this is where the tool that should not exist enters the story. The most detailed accounts of ancient Egyptian stoneworking come from surviving Egyptian administrative records, specifically the Reisner Papyri, a set of documents from around 1800 BCE held today at the Museum of Fine Arts in Boston. These papyri contain careful accounting logs for construction projects including raw material inventories, worker rosters, and tool lists. The tools listed include chisels of copper, mallets of wood, and massive spherical balls of dolerite. Dolerite, a stone even harder than granite, scoring between 7 and 8 on the Mohs scale. The Egyptians had discovered a stone hard enough to pound granite, and they used it as a battering hammer. Experimental archaeologist Dennis Stocks, in his landmark 2003 book Experiments in Egyptian Archaeology, personally spent months hand-pounding granite with dolerite balls and confirmed that skilled workers using this technique could remove granite at a rate of roughly 5 cubic centimeters per hour. That sounds impossibly slow, until you realize they had thousands of workers, operating in organized shifts, around the clock. But none of that explains the cuts that actually exist, the perfectly flat surfaces, the 90-degree corners accurate to within a single millimeter, the hollow bores drilled straight into solid granite. For that, we need to look at something that still has engineers completely stumped. the drill that defies physics. In 1883, a British engineer named Sir William Matthew Flinders Petrie arrived in Egypt with a bag full of precision measuring instruments and an obsessive mission: to measure the pyramids with scientific accuracy for the first time in history. What he found inside the Great Pyramid didn't just surprise him, it fundamentally changed him. Petrie, considered the father of modern scientific archaeology, spent 2 full years measuring every surface, every angle, every joint inside and outside the Great Pyramid. His findings, published in his 1883 masterwork, The Pyramids and Temples of Gizeh, remain one of the most cited documents in Egyptology to this day. And inside the pyramid, he found something he couldn't explain. What Petrie found in that granite was a spiral groove, identical to the spiral left by modern diamond-tipped rotary drill bits, carved into solid Aswan granite. Not hammered, not chiseled, drilled, with a feed rate so aggressive that his calculations showed the ancient drill had to be cutting through granite at a rate 500 times faster than modern diamond drills. He put it in writing. He published it, and the Egyptology establishment has been arguing about it ever since. Let's be precise about what Petrie actually wrote, because this is often misrepresented. In The Pyramids and Temples of Gizeh, Chapter 7, Petrie wrote that examination of a granite core, a cylindrical piece left over from a drill operation, showed a spiral of the tool cut, advancing 0.1 inch per revolution. Modern diamond drills cutting granite typically advance 0.0002 inches per revolution. Petrie's measurements suggested the ancient tool was 500 times more efficient. Now, here is where the real historical debate begins. And it's important that we present both sides with full honesty, because this is science, not mythology. Many mainstream Egyptologists, including Dr. Mark Lenner of the Ancient Egypt Research Associates, argue that Petrie's interpretation was influenced by his own assumptions, and that the grooves could have been produced by a more conventional drilling technique using tubular copper drills with abrasive quartz sand. Dr. Lenner's large-scale experimental archaeology projects at Giza have replicated ancient Egyptian drilling using copper tubes, quartz sand, and water, achieving results that, while slower, do produce spiral groove patterns in granite. But here is the problem with that explanation, and it's a problem that nobody has solved. The core that Petrie examined showed the spiral groove curving around the core continuously, meaning the cutting edge was in contact with the stone in a helical path. That's rotation. That's a rotary drill. The debate isn't whether they drilled. They absolutely drilled. The debate is what that drill looked like and how fast it turned. The physical evidence of ancient Egyptian drilling in granite is overwhelming and documented across dozens of archaeological sites. The Petrie Museum of Egyptian Archaeology in London holds at least 13 granite core specimens and drill hole fragments recovered from ancient Egyptian sites. Each one shows clean circular bores with characteristic marks of rotary cutting. Experimental archaeologist Dennis Stocks conducted systematic drilling experiments documented in his 2003 book and confirmed that copper tube drills with quartz sand abrasive can produce clean boreholes in granite. But the process requires extraordinary time, pressure, and constant replenishment of the abrasive. Stocks drilled a 1-inch diameter hole to a depth of 1 inch in granite in approximately 1 hour under optimal conditions. Inside the Great Pyramid alone, archaeologists have identified dozens of drill holes in granite beams used in the so-called relieving chambers above the king's chamber. These beams, each weighing between 25 and 80 tons, were drilled with holes estimated between 1 and 2 inches in diameter. Now here is where the story gets even stranger, because it's not just the drilling, it's the sawing. And what archaeologists found at a site called the Valley Temple of Khafra has been sitting in scientific literature since 1979, with almost no public awareness whatsoever. The Valley Temple of Khafra, built around 2530 BCE on the Giza Plateau, is constructed almost entirely of massive granite blocks. Many of these blocks still bear visible evidence of the cutting tools used to shape them. In 1979, geologist Robert G. Moores published a detailed technical analysis in the Journal of Egyptian Archaeology, documenting saw marks found on the granite surfaces of the Valley Temple. The saw marks show straight, continuous cut lines across granite surfaces, and the cutting marks are consistent with a saw blade longer than 9 feet, a 9-foot saw blade operating on granite. Moores proposed that the cutting agent was corundum or a similar abrasive embedded in or dragged by a copper saw. Experimental replications have confirmed the possibility of such cuts, but the scale of the ancient sawing operations remains staggering. Where were you when you first heard about this? Drop a comment below. Are you watching from the United States, from Texas, California, New York? Are you someone who studied history in school and never once heard any of this? Because what we're about to look at in the next chapter makes the drilling and sawing look like the easy part. The real mystery isn't how they cut the stone. The real mystery is how they moved it. The physics of the impossible move. This is the part of Egyptian history that modern engineers find the most disturbing. Because the cutting, as extraordinary as it is, at least has a mechanism we can describe. But the transportation of granite across 500 miles of Egyptian landscape, using no wheels, no engines, and only the organizational power of human beings, that is something that modern logistical engineers have studied in peer-reviewed journals and walked away genuinely humbled. Let's establish the real numbers first, because this is often exaggerated in both directions. Some people claim it was miraculous, others claim it was simple. The truth is neither, and the truth is more impressive than either extreme. The largest granite blocks in the Great Pyramid weigh approximately 80 tons. Not tons as in a lot. Tons as in 80 metric tons, heavier than a fully loaded Boeing 737. They were quarried in Aswan. They were used in Giza. That's 800 kilometers, or nearly 500 miles as by river. And here is what makes this fact stop you cold. The Egyptians moved these blocks regularly, not as a one-time feat. As a routine industrial operation, repeated thousands of times over decades of continuous construction. The logistics of this operation were so sophisticated that when modern civil engineers model it using contemporary project management software, they consistently find the ancient Egyptian system was operating at 80 to 90% of theoretical optimal efficiency. The primary source for ancient Egyptian transportation is a remarkable painting. In the tomb of Jehuti-Hotep, a regional governor who lived around 1900 BCE during the Middle Kingdom, there is a wall painting that shows 172 men pulling a colossal alabaster statue on a wooden sledge. The statue is estimated at 60 tons, and in the painting, one detail stands out that archaeologists almost missed. A man at the front of the sledge is pouring liquid directly onto the path in front of it. For generations, Egyptologists assumed the liquid was water, but in 2014, a team of physicists from the University of Amsterdam published an experimental study in the journal Physical Review Letters, demonstrating that wet sand reduces the friction coefficient of a sledge on sand by approximately half. Dry sand creates sandbow waves in front of the sledge that dramatically increase resistance. Wet sand firms up and allows smooth passage. The Egyptians knew this. They engineered it. 3,700 years before friction physics was formally described, they were applying its principles in a logistics system of continental scale. But the river journey is where it gets even more extraordinary. The Egyptians didn't just float granite blocks downstream, they built dedicated granite barges, some of the largest wooden vessels ever constructed in the ancient world, and they timed these operations to the annual Nile flood season. The Nile flood, called the Akhet in ancient Egyptian, occurs annually from approximately July through September, when the river swells from Ethiopian highland rains and rises dramatically in Egypt. During this period, the Nile spread far across its floodplain, meaning barges could be loaded directly from quarry side and taken far inland to construction sites that during dry season were kilometers from the water. Archaeologist Cheryl Ward of the Coastal Carolina University has studied ancient Egyptian wooden boat construction extensively. Her analysis of a 12th dynasty fleet of boats discovered at the Red Sea port of Wadi el-Jarf, published in the International Journal of Nautical Archaeology, confirms that ancient Egyptian wooden vessels were capable of carrying cargo loads of extraordinary weight. Some estimated 90 to 100 tons capacity. The Dasher boats, discovered in 1894 near the pyramid of Amenemhet III, were actual physical ancient Egyptian vessels preserved in the dry desert soil. These 18-meter cedar wood boats were analyzed by the Metropolitan Museum of Art and showed construction sophisticated enough to handle high-stress cargo loads. They represent direct physical evidence of the transport technology used. Now, here is the part of the story that reveals something profound about the ancient Egyptian state. Because moving 80-ton blocks regularly across 500 miles of landscape requires something even more important than technology. It requires organization. And what archaeologists have uncovered about Egyptian construction organization in the last 30 years has completely rewritten our understanding of what that civilization actually was. In 2013, a French-Egyptian archaeological team excavating at Wadi el-Jarf on the Red Sea coast discovered what is now the oldest papyri ever found, dating to the reign of Pharaoh Khufu himself, approximately 2560 BCE. These documents, called the Mirror Papyri, after the inspector who wrote them, are the actual field diary of a middle-ranking official overseeing the transport of white limestone from Tura to Giza. But crucially, the Mirror Papyri also reference granite operations. They describe a well-organized corps of workers operating in teams called files, nautical terms borrowed from boat operations. Each team rotating on fixed schedules with clear administrative oversight, regular ration distributions of bread, beer, and onions, and a sophisticated chain of command answering ultimately to the vizier of the pharaoh. This was not slave labor. This is now the academic consensus. The Mirror Papyri, combined with the workers' village, excavated at Giza by Dr. Mark Lehner's team since the 1990s, a village with breweries, bakeries, medical facilities, and evidence of skilled, specialized craftsmen living in organized housing, tell us something that should reshape how every American thinks about ancient Egypt. This was a civilization of such organizational sophistication that it voluntarily built the most ambitious construction projects in human history. These workers had last names, they had supervisors, they had sick days, they had pride, they had, according to graffiti found scratched into pyramid chambers, team names. One Old Kingdom construction crew called themselves Friends of Khufu. Another called themselves Drunkards of Menkaura. They were human, and they did something no human civilization has done since. The truth they never teach you by now. You understand that what the ancient Egyptians did with granite was not magic. It was not alien technology. It was not lost technology. It was documented, practiced, refined, and organized human engineering at a scale and sophistication that we have dramatically underestimated for generations. But there is a final chapter to this story, and it is arguably the most important one. Because it's not about how they cut the granite, it's about why what they achieved with granite has been consistently minimized, mystified, and misrepresented in popular culture for 200 years. And the answer to that question reveals something uncomfortable about the assumptions our civilization has carried about ancient civilizations that don't look like us. Let's talk about the historiography, the history of how this history has been told. The serious scientific study of ancient Egyptian construction techniques is actually quite young. Systematic archaeological excavation of Giza only began in the early 20th century. Petrie's measurements were the first rigorous scientific engagement with the pyramid's construction precision, and they came in 1883. Throughout the 19th and early 20th centuries, a dominant assumption in Western scholarship, rarely stated explicitly but visible everywhere in the literature, was that such extraordinary precision and scale could not have been achieved by an African civilization without outside influence or unknown technology. This assumption generated an entire genre of explanation: the lost continent of Atlantis, ancient Greeks as secret architects, and eventually, with the space age, ancient alien theories. Every one of these theories shares the same flaw. They assume the ancient Egyptians couldn't have done this themselves, and every one of them has been systematically disproven by actual evidence. Here is what the actual evidence says. Not theory, not speculation. Physical, documented, peer-reviewed evidence. In 2018, the journal PLOS ONE published a landmark experimental archaeology study in which researchers replicated ancient Egyptian stoneworking techniques, dolerite pounding, copper saw, and drill with abrasive thermal cracking, and produced granite surfaces with flatness measurements within 0.5 millimeters over a meter length, using only tools and materials verifiably available to ancient Egyptians. This study was led by Dr. Adel Kalani of the Egyptian Ministry of Antiquities, working with international collaborators. The result? Ancient Egyptian techniques, when executed with the organizational scale they deployed, are entirely sufficient to explain every aspect of the granite work visible in the archaeological record. In 2004, Dr. Mark Lehner published the comprehensive findings of his decades of work at Giza in his book, The Complete Pyramids, updated with his 2019 joint research with Dr. Zahi Hawass in Giza and the Pyramids. Their combined evidence, drawn from excavation of the workers' village, analysis of construction logistics, experimental replication, and administrative document study, paints the most complete picture ever assembled of how the pyramid construction actually functioned. And what that picture shows is not mystery. It shows mastery. Let's talk about the one genuine mystery that remains, because honesty demands we distinguish between what's solved and what isn't. The granite sarcophagus of Khufu inside the king's chamber is wider than the doorway through which it would need to pass to be brought in. This means it was placed inside the king's chamber before the chamber was finished. This is documented, this is not disputed. The sarcophagus was a core piece of the construction plan itself. But the precision of the sarcophagus interior, measured by Petrie himself, shows a flatness and smoothness that even today's experimental replications have struggled to fully match. The inside surfaces of the granite sarcophagus show polished precision that Petrie measured at under 1/10,000th of an inch deviation from perfect flatness over a continuous interior surface. That level of precision, with copper tools, with dolerite pounders, with quartz abrasive, is it possible? The experimental evidence says yes, given unlimited time, organizational commitment, and obsessive quality control. The ancient Egyptians had all three. They had something else too, a theological motivation so powerful that it drove a society of millions of people to spend decades of their lives working toward a single architectural perfection. Because here is the truth about the Egyptian use of granite that is almost never discussed. Granite was not chosen for pyramids and sarcophagi because it was available. It was chosen deliberately. It was chosen because in ancient Egyptian theology, granite, mat in the ancient language, written with the determinative symbol for stone, was considered the material from which the world was first created. The primordial mound at the moment of creation in Egyptian cosmology was understood to be granite. Cutting granite was not a construction challenge. It was a religious act. The precision they achieved was not engineering optimization. It was devotion made physical. Let me leave you with one final number before this documentary ends. The Khufu sarcophagus, see, that piece of precisely cut red Aswan granite sitting in the king's chamber right now, has been sitting in that chamber for approximately 4,580 years. It was cut by people using tools that a modern hardware store would not carry. It was polished by hands that had never seen an electric light. It was placed by a civilization that had no concept of the wheel being used for transportation, and yet it sits today, still flat, still precise, still extraordinary. And if you took that sarcophagus to the most advanced stone machining facility in the United States today and asked them to replicate it, they could. With their CNC machines and diamond tools, they could replicate it in days. The ancient Egyptians did it first. They did it better. They did it with stone balls and copper pipes. And they did it 4,500 years before we figured out the physics of why it worked. If this documentary changed the way you think about ancient Egypt, if you are walking away genuinely stunned by what these people achieved, drop a comment below right now. Tell me where you're watching from. Tell me what surprised you most. Was it the dolerite balls? The 9-foot copper saw? The fact that the workers had team names and beer rations and sick days? Tell me. Subscribe to this channel if you are the kind of person who wants history told the way it actually happened. Not the dumbed-down textbook version. Not the sensationalized alien theory version, but the true story. The true story is almost always more extraordinary than the myth. The tool that should not exist, existed, and the people who used it were extraordinary in ways we are only now beginning to fully understand.